So these two examples are correlated subqueries. Okay. Then in both examples, so the inner query is referring the values of outer query, and this inner query is executed for every row. Okay. Then now, suppose, for example, display top three maximum salaries. Already you know one method, display top three maximum salaries. You already know one method. What is that is? Using top class. That is one method. Let's say another method. Okay. Top three maximum salaries. Mhm. Okay. Oh. Hmm. Not using top class, using correlated subquery. Suppose what the logic is, this is salaries. One is 5,000, one is 1,000, 3,000, next one 2,000, suppose 4,000. This is salaries. I want top three maximum salaries. Then, so what are the top three? 5,000, 4,000, 3,000. No. See, what the logic is, it go to 5,000. Go to the first one, 5,000. And find out this 5,000 is less than how many salaries? Find out 5,000 is less than how many salaries? Listen, what is my question is 5,000 is less than how many salaries? Huh? 5,000 is not less than any. Okay, na? I'm not asking how many salaries are less than 5,000. I'm asking 5,000 is less than how many salaries? 5,000 is less than how many? Zero. Select 5,000. It is not less than any salary means it is bus max. Select 5,000. Yes or no? 4,000 is less than how many? 1. It is less than 1 means second maximum. Select 4,000. 3,000 is less than how many? 2. Less than 2 means third maximum. Select 3,000. 2,000 is less than how many? 3. Less than 3 means fourth maximum. Don't select 2,000. 1,000 is less than how many? 4. Means fifth maximum. Don't select 1,000. 5,000 is less than how many? 0. Then first maximum. Select 5,000. 4,000 is less than 1. Means second maximum. Select 4,000. 3,000 less than how many? 2. Means third maximum. Select 3,000. Next one. So 2,000 is less than how many? 2,000 is less than how many? Okay, na? It is less than what? 2,000. It is less than. Hmm. Hello. Hmm. Hmm. So 2,000 is less than how many? 3 means fourth max. Don't select. 4,000 is less than how many? 4 means fifth max. Don't select 1,000. Understood? So online students, can you hear me? Is my voice is audible? Hmm. Okay. Hmm. Okay then. Hmm. This is the logic. But once again, how to implement this logic in query? But this is a logic, but you have to implement this logic in query. First, see this, because I'll change this. See this. Select what salary from EMP as A, where 3 greater than. You see that. Select what's a count star. Count star from EMP B, where A dot shall less than B dot shall. This is a query. Okay, na? Understood? Then, now, see, listen this. So, first of all, this is correlated subquery or not? When you run this query, first SQL server checks whether this is normal subquery or correlated subquery. What is this? Correlated. Why? Why? Not general answers. Then don't tell the definitions. Why it is correlated subquery? Answer is A dot cell. That's all. That you have to tell. Not general answers. Okay, na? A dot cell. A dot cell is what? Inner query. Inner query is referring A dot cell, but A dot cell is coming from outer query. Inner query is referring the values of outer query. If inner query refers values of outer query, that is called correlated. You see the previous. X dot department number is coming from outer query. X dot department number is coming from outer query. Inner query is referring values of outer query. Then it is called correlated subquery. If it is a correlated subquery, execution starts from outer query. See, it go to the first record. It go to the first record. Execution starts from outer query. Yes or no? It go to the first record. You see this. First record. Apply the condition. What is the condition? 3 greater than. Sir, here, assume this is MPA. This is salary. Sir, understanding I'm taking 2 tables. But in database, how many tables are there? In database, how many tables are there? 1 table. 1000, 3000, 2000, 4000. Okay. Now, let's go to the first one. It go to the A table. Execution starts from outer query. Outer query table is A table. Apply the condition. What is the condition? 3 greater than. 3 greater than. Execute the subquery. Select count star from EMPB where A dot cell less than B dot cell. Okay. What is A dot cell? 5000. You're at first record. Execution starts from outer query. Outer query table is A table. It go to the first record. You're at first record. So what is the A dot cell? 5000. 5000 is compared with what cell? B dot cell. 5000 is compared with B dot cell. 5000 less than 5000? Huh? No. 5000 less than 1000? No. 3000? No. 2000? No. 4000? No. How many rows satisfying this condition? 0. What is the count value? 0. Count returns number of rows satisfying this condition. How many rows satisfying this condition? 0. Count value 0. Is 3 greater than 0? Yes. Condition true. Yes or no? Okay. Then. Okay. Now, it go to next record. What is the next record? 1000. Apply the condition. What is the condition? 3 greater than. 3 greater than. What is 3 greater than? What is the A dot cell? 1000. 1000 is compared with what? B dot cell. All the salaries of B table. 1000 less than 5000? Yes. 1000? No. 3000? Yes. 2000? Yes. 4000? Yes. How many rows satisfying? 4. Count value 4. 3 greater than 4? False. Next, go to the next record. 3000. So apply the condition. 3 greater than. Next one. So from EMPB, where A dot cell. What is A dot cell? 3,000. So 3,000 less than 5,000? Yes. 1,000? No. 3,000? No. 2,000? No. 4,000? Yes. How many? 2. Count value is 2. 3 greater than 2? Yes. Condition? True. Next one. Go to the next figure. 2,000. 2,000. Then apply the condition. 3 greater than. 2,000 is less than how many? 5,000, 3,000, 4,000. 3. 3 greater than 3? False. Not selected. 4,000. Apply the condition. 3 greater than. How many? 1. 3 greater than 1? Yes. Condition 2. Okay. Then. Okay. Now. But one second. Let me run the query. I'll execute the query. Execute the query. Then. But you see whether you'll get the expected output or not. 5,000, 3,000, 3,000. You're asking for top 3 maximum, but it is giving top 2, not top 3. 5,000, 3,000, 3,000. No. Why? Because there are 2 employees. There are 2 employees sending what's it? 3,000. There are 2 employees sending 3,000. Actually, it is, you're asking for top 3, but it is showing top 2. 5,000, 3,000. Yes. Why? Because of duplicates. Eliminate the duplicates. Eliminate what's it? Duplicates. Eliminate the duplicates in counting. Eliminate the duplicates in outputs. You have to eliminate eliminate the duplicates in counting. Eliminate the duplicates in output. How to eliminate the duplicates? Distinct. Distinct to what? B dot sal. Distinct B dot sal. I'm not counting all the values. I'm counting only distinct values. Now let me run this. Now what you are getting? 5,000, 3,000, 2,975. Now you are getting top 3. Yes or no? Yes. In the output also, I want to eliminate the duplicates. In the output also, I want to eliminate the duplicates. Then what? Distinct. Apply distinct here also. 5,000, 3,000, 2,900. So duplicates are eliminated or not? Yes. But I want to show this in descending order. First, I want to show 5,000, next 3,000, next 2,975. Then use what? Order by. Order by salary. What's it? Descending. 5,000, 3,000, 2,975. So this is the query to display top 3 maximum salaries. Sir, I'll take example. I'll take example with duplicates. I'll explain. Okay. Then first note on this. Yeah. Hmm. No. Let's see. One second. Hmm. No. See this. First, one second. Let's see this example. Sir, without distinct, you'll understand. Without distinct. Now, let's take duplicates. Let's take what's it? Duplicates. This is what? 3000. This is also 3000. I'm taking duplicates. Now see what you will get. I'm asking for top three maximum. Let's see. I'm not using distinct. No. It go to the first one. What the condition? 3 greater than. 5000 is less than how many? 5000 is less than how many? 0. Then 3 greater than 0. Condition what? True. 3000. Now apply the condition. 3 greater than how many? So 3 greater than 3, like, sorry, 3000. 3000 is less than how many? It is less than 5000. Yes. Less than 4000. Yes. 2. Then condition what's it? True. Yes or no? Next one. Next. Next one, what's it? Next one is also what? 3000. Okay, 3000. Then hmm? 3 greater than what? 2. 3000 is less than 5000. Yes. 3000. No. 3000. No. 2000. No. 4000. Yes. How many? 2. Condition what's it? True. Next one. 2000. 2000 less than 5000. Yes. 3000. Yes. 3000. Yes. 2000. No. 4000. Yes. How many? 4. 3 greater than 4. Condition false. Next one. 4000. 4000. 4000 less than 5000. Yes. 3000. No. 3000. No. 2000. No. 4000. No. How many? 1. 3 greater than 1. Yes. Condition what's it? True. Okay. No? Then what are selected? What are selected? What are selected? Condition true. Condition true for 5000, 3000, 3000. Next 4000. So what are selected? 5000, 3000, 3000, 4000. Yes or no? But I don't want to see the duplicates. Then distinct. Apply what? Distinct. Understood or not? Apply the distinct. When you apply the distinct, duplicates are what? Eliminated. Okay? Then. No. So then. That's why what I'm doing is I'm applying the distinct. Applying the distinct in counting and applying the distinct in what's it? Display. In counting also eliminating the duplicates, in display also eliminating the duplicates. That's it. If you don't use a distinct, duplicates are displayed, but you don't want to see the duplicate, then eliminate the duplicates. 5000, 3000, 4000, 2975. Okay? Then. So top three maximum salaries. Understood now? Now, next. But this is showing top three. I want top five. Then I want top five. Five greater than. Five greater than means what is selected? Count zero. Count zero means first maximum. Count one is selected. Yes, second maximum. Count two, third maximum. Count three, fourth maximum. Count five, fifth maximum. Count zero, first maximum. Count one, second maximum. Count two, third maximum. Count three, fourth maximum. Count to four, fifth maximum. Okay, then. So it will show top five, top five, 5,000, 3,000, 29, 28, 2450. Top five maximum. Okay, then. So by using this, we can get anything. Okay, then. Suppose, like, sir, when top fails, like you think we can also write this by using what? Top clause. Yes or no? From EMP, order by salary, what? Descending. So you'll get salaries in descending order. But you want top three maximum. Suppose like distinct. If you apply the distinct, duplicates are eliminated. Suppose I say top three, then top three maximum. If I say five, then top five maximum. So we can also write this using top class, using correlated subquery. But sometimes top class is not fails. Sometimes top class cannot be used. Like what is my queries? Display third maximum salary. Display third maximum salary. Okay. I don't want top three maximum. I want only third maximum. So can we do this using top class? Huh? Can we use this? Can we write this using top class? No. So using top class, you can get first top three, top five, top five. Okay. But I want only third maximum. I want only fifth maximum. Can we do this using top class? No. But can we do this using correlated subquery? Yes. See, first maximum count is what? Huh? First maximum count is what, sir? First maximum count is zero. See, count to zero means zero equals to. Count equal to zero means what? First maximum. Count to zero means first maximum. Count to one means second maximum. Count to two means third maximum. Count to three means fourth maximum. Yes or no? So if I ask third maximum salary, count should be what? Two. Count to two. Count to two means third maximum. Count zero means first maximum. Count to one means second maximum. Count to two means third maximum. So instead of writing two, I write 3 minus 1. Instead of writing two, 3 minus 1. 3 minus 1 means 2 only. Instead of writing 2, I'm writing 3 minus 1. Why? Because convenient. Why convenience? See, third maximum, here you write 3. For fifth maximum, instead of 3, 1. See, third maximum, if you write 3 here, you are getting third maximum. If you want fifth maximum, instead of 3, what? 5. Then you'll get what? Why 4? Fifth maximum. Fifth maximum, not fourth maximum. What? Fifth maximum. Here you write 1. Then first maximum. 1 minus 1, 0. Count 0 means first maximum. Yes or no? Then see, 1, first maximum. Here you write 2, second maximum. Here you write 3, third maximum. Whatever you write it here, that maximum. You write n, nth maximum. Yes or no? Okay? Then. So that's why I'm writing minus 1. Convenient. So whatever value we give it here. If you give 10 here, then you'll get 10th maximum. Okay? Then. No. So query to display third maximum salary. Okay, that's it. Okay. So this gives nth maximum. If you pass n value 5, fifth maximum, n value 1, first maximum. Okay, then. So whatever value you pass it here, you will get that maximum. That's all. So what this is? This is what like query to get top 3 maximum maximum. Okay, na? Sir, you can write this query. You can write this using what? You can write this using top class. But you cannot write this using top class. Third maximum. Only third maximum. You cannot do this using top. But using this, we can get anything. Okay? Then. Like this. But the next one is, see, like next, derived tables. Derived tables. Hmm. In all our examples, where you written subqueries, okay, in our in our examples, where you written the subqueries, where class, where written the subqueries, where class. You written subqueries in where class. Yes. Then what are derived tables means? Subqueries in from class. Subqueries in from class are called derived tables. You can also write subqueries in from class. If you write subqueries in from class, they are called what? Derived tables. Then so subqueries in from class are called derived tables. Then, mm. So up to now you written subqueries in where class, but if you write subqueries in from, they're called derived tables. Select what columns from. Here you write what select statement as alias. Next what where condition. So this is the syntax. What this is? This is what subqueries in subquery. Subquery in from class. So if you write subqueries in from class, there is a name to subquery. What that is called? Derived table. Hmm. And sir, actually, what should be there yet? Hmm? What should be there yet? Hmm? What should be there yet? Actually, in usually in queries, what we write here, table name. You write table name. You're writing subquery in place of what table name. Okay, then. So that means here this subquery output acts like a table. The subquery output acts like a table for outer query. The subquery output acts like a table for outer query. Sir, up to now, where you return subqueries, you return like this column name, operator, select statement, yes or no. So actually, what should be there here? What should be there here? Value should be there. In place of value, you return subquery. Here, the subquery output acts like a value. Here, the subquery output acts like a value. Here, the subquery output acts like a table. That means subquery output acts like what depends on where you write it. You write it in where class, output acts like a value. You write it in from class, output acts like a table. Okay. Then here the subquery output acts like a table for outer query. Subquery output acts like a table for outer query. Now, so what is query returns? Any query. Query returns what? You run a query bus, select statement, select star from EMP. What is query returns? Then what is query returns? What such? Okay, query returns what? Rows and columns. What is query returns? Rows and columns. Table also contains rows and columns. Query also returns what? Rows and columns. So that means this query output acts like a what? Table. Okay, then. So what for derived tables? Derived. Derived tables are used in following scenarios. Derived tables are used in following scenarios. So when we use derived tables, they are used in the scenarios. One is to control order of execution of clauses. Next one, to use result of one operation in another operation. Next one, to join two query outputs. Join query outputs. Join query outputs. To join query outputs. There are two queries are there. I want to join the query outputs. So then also we use derived tables. So derived tables are used in following scenarios: to control the order of execution, to use result of one operation in another operation, to join query outputs. Okay. Now, so first let's see controlling order of execution. Okay. Controlling what? Order of execution of what? Clauses. Controlling order of execution of clauses. Okay. Then what is this? Okay. Then what is the default order? The default order. By default, SQL Server execute the clauses in what order? What is the default order of execution? Hmm? The default order of execution is what? First what? From, next, where, next, group by, next, having, next, select, next, order. So this is order of execution, default order of execution. Okay. Then the default order of execution of clauses. First from, next, where, next, group by, next, having, next, select, next, order by. Okay. Then, but I want to control this order. I want to control this order. Means controlling this order means like you take where and order by. You take where and order by. Which is executed first, which is executed next. Where is executed first? Order by is executed next. But first I want to execute, sorry, default first where, next order by. But what is my requirement is first I want to execute order by. Next I want to execute where clause. That means before applying the where condition, I want to sort. First I want to sort. After sorting, then apply the where condition. That is my requirement. Then default is this pass, but what I want is first I want to execute order by, next I want to execute where clause. Then what? Use what? Derived tables. Okay. Then see, you take where and select. which is executed first. First what? Where clause, then select. But what is my requirement is first I want to execute select, then I want to apply the where condition, then use what? Derived tables. So default order is this. If you want to control this order, then use derived tables. Okay, then so then to control this order of execution, use what? Use derived table. Example. Example. So to control this order of execution, use what? Derived table. Okay. Then now let's see. Example. Suppose then what is the question is display ranks of the employees based on salary. And highest paid should get first rank. You already know this. Then I want to show ranks of the employees that is based on salary and highest paid should get first rank. Okay. It's what? Tell me what you already know. Employee number, name, salary, rank. For ranking, there are two functions. One is rank and dense rank. I'm using dense rank. Dense rank over ranking is based on salary, but highest paid should get first rank. Then order by salary. What? Descending as RNK from EMP. What this query will show? Each and every employee's what? Rank. This query will show each and every employee's rank. You see this. So it is showing ranks of the employees. 5,000 gets what? First rank. And these two employees' salaries are what? Same. The ranks are also same. Next one is what? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So this query is showing each and every employee rank. Okay. Then, so the above query displays ranks of the all the employees. Above query displays ranks of all the employees. But to display top 5 employees, then I don't want to display all the employees. I want to display top 5 employees. Top 5. Then forget about top class. Leave it. Top class, you leave it. Ah, this query returns ranks of all the employees, but I don't want to see all the employees. I want to display top 5 employees. Then top 1 employee rank is what? 1. Top 2 employee rank is 2. Next 3. Next 4, 5. So if you want top 5 employees, then if you want top 5 employees, select rank up to 5. If you select rank up to 5, you'll get top 5. Yes or no? Then, so to get top 5 employees, select rank up to 5. Okay, then what is the condition? Where rank less than or equals to 5. So the above query returns ranks of all, but my requirement is top 5 employees. To display top 5 employees, select rank up to 5. But to select rank up to 5, what is RNK? What is RNK? Okay, now RNK is what? Alias. Alias cannot be used in what's that? Where class. So what this query gives? Error. This query gives error. Why? Why? Because so here where you declared the alias, where you declared the alias, select. Where you declared the alias, select. Where you are using the alias, where class. It is declared in select. It is used in where class. But where in select, which is executed first, where is executed first, select is executed next. That means first you are using the alias, after that you are declaring the alias. Sorry, alias is declared in select, alias is used in where. But you are using this first, after that you are declaring. That is not allowed. First declare, then use. Sir, in programming languages, you use variables. First what? Declare the variable, then use the variable. Here also, alias also. First declare the alias, then use the alias. So, but here what you are doing is first you are using the alias, but after that you are declaring the alias. That is not allowed. That's why this query gives what? Error. Okay, then now. So column alias cannot be used in where clause because where clause is executed, where is executed before select. Here the problem is order of execution. Here the problem is related to what? Error. Error is related to order of execution. Okay. How to overcome this? To overcome this problem, what? Use what? Derived table. Here, anything related to order of execution to overcome the problem, use what? Derived table. Okay, then. So here, which one you want to execute first? Which one you want to execute first? If you want to use this alias and where class, you have to execute which one you have to execute first. Select. First execute select, then execute where. Then it will work. First, if you declare, then use it, then it will work. First, declare the alias, then use the alias. But here, first you are using the alias, after that you are declaring. That is not allowed. First, declare, then use. So, which one you want to execute first? Select. You want to execute this select first. Which one you want to execute first? Keep it in inner query. Which one you want to execute first? Keep it in inner query. Which one you want to execute next? Keep it in outer query. Because inner query, outer query, which is executed first? Inner query. So the one which you want to execute first, keep it inside. The one which you want to execute next, keep it outside. Okay, then. So now I write like this. What is select what's a star from what? Select what? EMP, NO, E name, salary, what? Dense rank over order by salary descending as RNK from EMP. Then as E, as E. So then, which is executed first? Inner query. Inner query is executed first. Here, outer query, inner query, which is executed first. Inner query is executed first. What is inner query returns? Inner query returns what's it? ranks of all the employees. You are giving name to this output. What is the name given to this output? E. That means this query output is stored in temporary table. This query output is stored in temporary table. What is the temporary table? E. Storing this query output in temporary table. That is what, sir? E. Actually, E is called what? E is called what? E is called derived table. Okay. Then, so this query output is stored in temporary table called E. Okay. Now, outer query is selecting the data from what? Outer query is not selecting the data from EMP table. Outer query is selecting the data from E table. So what is E table contains? Number, name, salary, rank. Okay. E table contains how many columns? 4 columns. How many rows? 14 rows. E table contains 4 columns and 14 rows. Okay. Then I don't want all the rows. I want only first 5 rows, top 5. Then where RNK less than or equals to 5. That's all. So can I use RNK in outer query? Yes or no? Yes, because where it is declared? Where RNK is declared? Inner query. So it is declared in inner query. It can be used in outer query. Then alias cannot be used in where clause. If you want to use alias in where clause, then what? Derived table. Okay. So this query returns what's at top 5. No. Okay, na? Then. Okay. So, but here, then I want only salaries. This is showing numbers, name, salary now. So it is showing number, name, salary, rank. But I don't want other details. I want only top 5 maximum salaries. Then what's that? Display what? Top 5 maximum salaries. Then top 5 maximum salaries. Then what? Don't select all the values. Select only what? Salary. Then don't select all. Select only salary. Just 1 second. You see this. Then 5,000, 3,000, 3,029. Top 5. Yes. Only salaries. Top 5 maximum. But don't show the duplicates. Then apply what? Distinct. Apply the distinct. So duplicates are eliminated. But after applying distinct, it is sorted in ascending. But I want descending. Then order by. So use order by. Order by salary what? Descend. So descending order. Okay. Then. So this is another method to get top 5 maximum. Just now we have seen one method. What that is? Okay. So this query, the previous query is displaying what? This previous query is displaying top 5 employees, top 5 employees details, number, name, salary. But what this query is displaying? Top 5 salaries. The previous one, top 5 employees, but this is top 5 salaries. You want to see the employee details? write this. You want to see only the salaries, write this. Okay, then. So it will show only salaries because you are selecting only salaries. Why distinct? Because you don't want to see the duplicates. How to eliminate the duplicates? Distinct. Okay, then. Hmm. One fifth maximum salary. Then you want fifth maximum salary. Then what? First maximum rank is first maximum rank is not zero. First maximum rank is one. Rank starts from one, not from zero. First maximum rank is one. Second maximum rank is two. Third maximum rank is three. Fourth maximum four. Fifth maximum five. So you want fifth maximum. Then rank should be equals to five. Rank equals to five. Okay. Then rank equals to one. Then first maximum 5,000. Rank two. Then second maximum 3,000. Rank three. Third maximum. Rank four. Five. Fifth maximum. Okay. Then so like display fifth maximum salary. Same query, but only where condition is different. Then RNK equals to 5. Even order by is also not required. Why? Order by is required or not required? Not required. You are showing one salary na multiple. One salary. When you are displaying one salary, why sorting is required? Yes or no? Then so rank equals to 5. That's all. Now you know three methods. Top three maximum. Top three maximum salaries. You know three methods. What are the three methods? Okay. Then it's so this is one example for derived table. Okay. Next. Sir, I want to show the row numbers. You know now row numbers. Then see, suppose here this is the table. I want to show the row numbers. I want to show the row numbers. 7369. Row number one. Second record two. Third record three. Fourth record four. Fifth record five. Not rank. Rank is different. Row number is different. Row number means sequence numbers. First record one, second record two, third record three, fourth record four. Like how to show the row numbers? Huh? Yeah. So what we use? We use a function called what? Row number over. Row number is based on what? Here. This should get first row number one. Here row number two, row number three, row number four, row number five. Like then what? Row number is based on what? Employee number. In table, how the rows are arranged? In table, how the records are arranged? Employee number wise. Here also I am arranging what? Employee number wise. Table order, this query order is same or not? Yes. In same order, you'll get the row number. In table, first record gets row number 1. Second record gets row number 2. Third record gets row number 3. Okay. Then you see that 7369 is what? 1. 7499 is 2, 3, 4. Then so what is this query gives? This query gives what? row numbers. Every record is displayed with what? Row number. Then now okay. You have to write query like this: number, name, salary, plus what? Row number over. But how you want to show the row numbers? Same order, they're in table. In table, first record 7369. First record should get row number 1. I want to give row number 2 to the second record. So in whichever the order records are there in the table, in the same order, I want to give the row numbers. And then what you have to say? Order by EMP NO ascending as RNO from EMP. So what this query gives? This query gives what? Row numbers. Okay. So every record is displayed with record number, row number. But this query displays all the records. But I want to display first 5 rows. Then the above query displays all the records with what? Row number. But to display first 5 rows, then what? First record row number is what? Second record row number is 2. Third record row number is 3. Fourth record is 4. Fifth record is 5. Sixth record is 6. But if you want first 5 rows, then select row number up to 5. How to select row number up to 5? Write where condition. Okay, na? Then 1 second. Where what? RNO less than or equals to 5. But if this works, if this query will work? No. Because what is RNO? Alias. Can we use the alias in where class? No. Then what is the solution? Derived table. Then how to write it? Select star from. Select star from. Then row number over then from EMP as E where row number less than 5. Now it will work because where you declare the RNO? Where you declare the RNO? Inner query. Where you are using the RNO? Outer query. So declared in inner query, used in outer query. Now it will work. You see this. Then, so what this is showing? First 5 rows from table. Okay, first 5 rows from table. I want only fifth record. Then row number equals to 5. I want fifth record, seventh record, 11th record. Fifth, seventh, 11. Row number in 5, 7, 11. I want fifth record to 10th record. Row number between 5 and 10. I want I want even number records. I want even number records. Second record, fourth record, sixth record, eighth record. Then even number records. Row number modulus 2 equal to 0. So divide row number with 2. Remainder is what? 0. Then even number. Okay. Then you see this. 1 second. Row number equals to 5. Then what it does? Fifth record. Row number in 5 comma 7 comma 11. So it will return fifth record, seventh record, 11th record. Row number between 5 and 10. Then what it returns? Fifth record to 10th record. Even number records. Modulus 2 equal to 0. Then it returns 7, 2, 4, 6, 8, 10, 12. Odd number. Then equal to 1. Odd number. 1, 3, 5, 7, 9, 11. Okay. Then, all these queries are related to what? All these queries are related to this one. This is related to fetching the records from table based on record numbers. Fetching the records from table based on record number. First 5 rows. Fifth record, seventh record, 11th record. Even number, odd number. Okay. Fifth record to 10th record. So all this based on what? Record numbers. Then you have to use what? Row number plus derived table. You have to use 2. What that is? Row number plus derived table. I want top 5 maximum, 5th maximum, 10th maximum salary. Then dense rank function plus derived table. Okay. Top 5 employees, 5th maximum salary, 10th maximum salary. Then you have to use dense rank plus derived table. Here, first 5 rows, 5th record, 10th record, 11th record, even number, odd number. Then use row number plus derived table. So display last 3 rows. Then I want to show last 3 rows. What? Hmm? I want to show last 3 rows. What? Hmm? Last 3 rows. Then last 3 rows. Suppose table contains 14 rows. If table contains 14 rows, then what do you want? Last 3 rows means 12, 13, 14. 12th record, 13th record, 14th record. If table contains 20 rows, then 18, 19, 20. Okay, that means here, what you have to give? 14 rows, then you have to give 12. Row number greater than or equals to 12. Row number greater than or equal to 12 means 12, 13, 14. So what this gives? This gives 12th record, 13th record, 14th record. If a table contains 20 rows, then here you have to give 18. If table contains 50 rows, then you have to give 48. But I don't know how many rows are there in the table. Then I don't know how many rows are there in the table. What is the common logic? Table 14. If 14 rows, then what is the number you have to give? 12. 20 rows, 18. 50 rows, 48. That means number of rows minus 2. Number of rows minus 2. How to find number of rows? Counts are. Then you have to write like this. What is, select what? Counts are minus 2 from EMP. So this is, what this gives? Number of minus 12. Because how many rows are there? 14 rows. So this query returns 12. Then row number greater than or equals to 12. Row number greater than or equal to 12 means what? Then what this gives? 12, 13, 14. So this will work only for the table of 14 rows or any table. Any table. If 20, then what is this query returns? 20 minus 2, 18. Okay. Then. So this query will show last 3 rows. So this query will show last 3 rows. So all these queries are based on row number. Yes or no? Then the previous one is based on ranks. Okay. Top 5 employees, 5th maximum, 10th maximum, like that is then use dense rank and derived table. If based on record numbers, use row number and derived table. Okay. But it is showing now displaying that first, like displaying the last 3 rows, but not displaying. Suppose what is my query? Delete first 3 rows from EMP table. Not display. What? Delete. Then what? Instead of select, select means display. Delete means delete. Then what? What you write? Delete from. Okay. Instead of select, what you write? Delete. Delete from where? Row number what? First 3 rows now. Row number less than or equal to 3. Then delete from row number less than or equals to 3. Execute this query. So previous queries displays, but I want to not display. I want to what's her? Delete. I want to delete. Then now run this query. Run this query. Then what this query gives? Error. This query gives what's it? Error. Okay, na? No. Why? Alias. Remove the alias. Okay. Then will it work? Okay, na? Then see, sir, what's the point here? Then in derived tables, outer query cannot be DML. Derived tables outer query cannot be DML. It must be always what's that? Select. In derived tables, outer query cannot be DML command. Outer query must be always select. So it must be always select. Now, let's see. But here outer query is what? Outer query is what, sir? Delete means DML. Yes. Outer query cannot be DML command. Outer query must be always select. But here you are writing delete. That's why it is giving error. Then how? What is the solution? But my requirement is not display. My requirement is what, sir? Delete. Then what? What the solution is? What? The solution is CTE. What is CTE is? Okay. Then CTE stands for common table what expression. CTE stands for common table expression. Okay. Then using CTE, we can give name to the query output. Using CTE, we can give name to the query output, and we can refer that name. We can refer that name in another query. We can refer that name in another query like select, insert, update, delete. Using CTA, we can give name to the query output and we can refer that name in another query like select, insert, update, delete. Okay. Okay, na? Then. Sorry, here also what we are doing, giving the name to the query out. Here also you are giving the name to the query output. In derived table also you are giving the name to the query output. So this is the query. You are giving name to this output. What is the name given to this output? E. But can we use this name in another query? Can we use this name in another query? No. Sorry, you are giving the name, but can we use this name in another query? No. But in CTEs, we can give the name to the query output, but we can refer that name in what? Another query. Select, insert, update, and what's her? Delete. Okay? Then. So, another, like in derived tables, outer query cannot be. In derived tables, outer query cannot be DML. Outer query cannot be DML. But in CTs, outer query can be DML. Outer query can be select, insert, update, delete. Okay. Then in derived tables, outer query cannot be DML. It must be always what? Select. But in CTS, outer query can be DML. Now, how to use this? We must use like this. What then? With what? Alias, CTE name or CTE expression name, CTE name as what? What is this? Is select statement. Then you are giving the name to this output. So that is CT name. Next one. Next, this is outer query. Outer query can be select, insert, update, delete. But in derived tables, outer query is always select. But here, outer query can be select, insert, update, delete. Okay. Now let's take example. Let's take one example. Example one. Ah, what do you want? What do you want? Delete what's it? Huh? First three rows. Delete first three rows from EMP table. Okay. So this is not possible using. This is not possible by using derived tables. Why? Because in derived tables, outer query cannot be DML. But let's come to this one. What with what? Follow the syntax. With suppose E with E as then what? Now write the select query. Write the select query. Generate row numbers. How? You know that. What? Number, name, salary, what? Row number. Then order by EMPNO ascending as RNO from EMP. So first, what is executed? This query is executed. What is this query returns? This query returns what? Row numbers. What is this query returns? Row numbers. So for every record, it generates what? Row number. 1, 2, 3, 4 like this. Then you are giving some name to this output. What is the name given to this output? E. But from this E, I want to delete first three rows. What is delete first three rows? Huh? I want to delete first three rows. Then what? Delete from what's it? From E. Delete from E where what? First three rows. How to access first three rows? Row number less than or equals to 3. Row number less than or equal to 3. So what is this command will? Delete first three rows. Deleting from E means deleting from EMP table. So delete from E means delete from EMP table. Whatever action is performed on E, the same action is performed on EMP table. If you update E, then what is updated? EMP table is updated. If you delete from E, then deleted from EMP table. Okay. So whatever action is performed on E, the same action is performed on what? EMP table. Okay. Then now run this, execute this. Then so execute this. What it says? Three rows affected. Three rows are what's it? Deleted. Now go and see the table. Which table? EMP table. Select star from EMP. Select star from EMP. Okay. Now see that how many rows? 11 rows. Actually 14. Three rows deleted. 11. Then so any operation performed on E means operation is performed on EMP. Then okay. Hmm. Then, for example, okay. Then suppose that there is a table like this EMP 55. One field is ENO, E name salary. 1A what 5,000. 2B 6,000. 3C 7,000. 1A 5,000. 2B 6,000. Okay. Then what I want is I want to delete the duplicate rows. I want to what? Delete what? Duplicate rows. So these two rows are what? Duplicates. I want to delete these duplicate rows. Okay. This is one duplicate row. This is one duplicate. So these two rows are duplicate rows because there is one record with same number, same name, same salary. There is one record with same number, same name, same salary. So that's why these two records are called duplicate rows. I want to delete these duplicate rows. Then how? Then what the logic is, okay, then first group the records with same number, same name, same salary. Group the records with what? Same name, same salary. How many records are there with same number, same name, same salary? Two records. Just make this as one group. There is another like 2B 6,000. 2B 6,000. How many records are there? Two records. There is one. 3C 7,000. How many records are there? One record. Okay. So group the records with same number, same name, same salary. How many groups are created? Three groups. Generate the row numbers within the group, not in the whole table. Generate the row numbers within the group. What is the row number? 1. What is the row number? 2. Here, what is the row number? 1, not 3. 2. What is the row number? 1. Because row number is not in the whole table. Row number is within the group. So first, group the records with same number, same name, same salary. After grouping, generate the row numbers within the group, not in the whole table. Okay. Then next, after generating the row numbers, now delete the records whose row number is greater than 1. Delete the records whose row number is greater than 1. So this record row number is greater than 1. Yes, delete this record. This record row number is greater than 1. Yes, delete this record. Now what are deleted? Duplicates are deleted. Delete the records with row number greater than 1. So this record row number is greater than 1. Delete this. This record row number is greater than 1. Delete. Yes or no? Okay. Then. So this is the logic. First question is how to group the records with same number, same name, same salary. How to group the records with same number, same name, same salary. Huh? How to group the records with same number, same name, same salary. Sir, here, 1 second. I want to generate the row numbers. I want to generate the row numbers within the department. Sir, not in the whole table. I want to generate the row numbers within the department. So just make the 10th department is one group, 20th is one group, 30th is one group, and within the department generate the row number. How? What you have to write? You have to write something like this. What that is then? Suppose select what? EMPNO, e-name, salary, next what's that? Department number. Then what? Row number, then over, then order by means like I want row numbers within the department. I want row numbers within the department, not in the whole table. Then what we have to use, partition by department number, and within the department, which one should get row number 1, which one should get row number 2. That is based on what? Employee number as RNO from EMP. Okay, from EMP. From EMP. So row number over partition by department number, order by employee number as RNO from EMP. Okay, then now let's see what this is. What this is. Now row number is what? Within the department. 10th department is one group. So 1, 2, 3. 20th is what? One group. 1, 2, 3, 4. 30th is what? One group. Within the group 1, 2, 3, 4. Now row number is within the group. Then in this case, what I said, like generate the row numbers within this group. Make the employee number, name, salaries are same. Then make it one group. Then, sir, earlier department numbers are same. Make it one group. If number, name, salary is same, then make it one group. Then what you have to say? Partition by ENO, comma, E-name, comma, salary. Now you have to write like this. What is partition by ENO, comma, E-name, comma, salary? What is the meaning? If number, name, salaries are same, then it becomes one group. So 1A 5,000 is one group. 2B 6,000 is one group. 3C 7,000 is one group. Now it will generate the row numbers within the group. Understood or not? Okay. So we'll write this query in the next class.